What is heat, and why is it so important? Heat is a form of energy that moves between objects or systems due to temperature differences. It's essentially the total kinetic energy of particles, like atoms and molecules, in a substance. The higher the kinetic energy, the hotter the temperature, and the more heat present. Heat is everywhere around us, from the warmth of a sunny day to the chill of a winter breeze. Heat doesn't stay put. It moves, but how? Well, heat transfer is a fascinating process that happens in three main ways: conduction, convection, and radiation. Imagine heating a pot of water on the stove. The heat from the flame is conducted through the metal of the pot, making the water warm. This is conduction, the transfer of heat through direct contact. But what about convection? Let's stick with our pot of water. As it heats up, the warmer water rises, and the cooler water sinks, creating a circular motion. This movement of fluid due to temperature differences is convection. And finally, think about feeling the warmth of the sun on your skin, even though it's millions of miles away. That's the work of radiation, the transfer of heat through electromagnetic waves. So heat transfer is all about the flow of energy from a hotter object to a cooler one. How do we measure heat? Well, the standard units of heat in the International System of Units, or SI, are joules. Now, let's talk about specific heat. This is the amount of heat energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius. So, in essence, every substance has its unique heat capacity, which determines how much heat it can hold. Heat is not just about feeling warm or cold. It's central to the science of thermodynamics. Thermodynamics, in a nutshell, is a branch of physics that studies the movement and conversion of heat into different forms of energy. It's all about the relationships between heat, work, and energy transformations in physical systems. Heat plays a pivotal role in these transformations. For instance, in a steam engine, heat from burning coal is converted into mechanical work. In your refrigerator, work is done to pump heat from the inside to the outside, keeping your food cold. Even in our bodies, heat generated through metabolic processes helps maintain our vital body temperature. In every energy transformation, heat is either absorbed or released, driving the process forward. It's a beautiful dance of energy, orchestrated by the laws of thermodynamics. Now that we know what heat is and how it works, let's dive into some fascinating facts about heat. Did you know the charming glow of a campfire has more to it than meets the eye? While it takes roughly 450 degrees Celsius to ignite a wood fire, the average yellow flame can reach temperatures of a staggering 2,000 degrees Celsius. If the flame turns bright blue, it's even hotter, soaring close to 3,000 degrees Celsius. Speaking of high temperatures, to melt a diamond, one of the world's most valuable substances, you'd need a temperature of a whopping 3,550 degrees Celsius. That's right, diamonds might be forever, but under the right conditions, they too can melt. Meanwhile, at the Earth's core, temperatures are mind-boggling. Right in the center of our planet, the temperature hits 5,377 degrees Celsius. That's hotter than the surface of the sun. And speaking of the sun, the core of our star is a furnace like no other. Here, nuclear fusion occurs, with hydrogen atoms fusing to form helium. This process generates an immense amount of energy, raising temperatures to a staggering 15 million degrees Celsius. But the sun isn't the only thing that can get that hot. Controlled nuclear fusion, a process where two or more atomic nuclei collide at high speeds, has recorded temperatures of 100 million degrees Kelvin. That's hotter than the core of the sun. Before moving to Big Bang, please subscribe, like, and share the video. Finally, let's take a trip back in time to the Big Bang, the event that birthed our universe. 10 seconds after the Big Bang, the estimated temperature was an unfathomable 141 nonillion degrees Kelvin. That's a 1, followed by 60 zeros. From the heart of our planet to the farthest reaches of the universe, heat is a fundamental part of our existence. So, we've journeyed from the basics of heat to its role in the cosmos. Next time you feel the warmth of the sun or the heat of a fire, remember the incredible science behind heat.